This is section 5B, dividing rational expressions. So instead of multiplication, we're going to do division. And if you recall from back when we worked a lot more with just regular fractions, if you had something like 5/3 divided by 1/2, dividing fractions means multiplying by the reciprocal, multiplying by the flip of the second number. So this is equivalent to saying 5/3 times 2/1. So all we did is we took that second thing, flipped it, and we changed from division to multiplication. So if we go down to number 11, you see we have 3/8 divided by 4x squared over 3x. What we could say instead is 3/8, we keep the first one the same, times the flip of the second. So this one gets flipped. So we have 3x over 4x squared. And then we solve it just like the earlier problems, the multiplication problem. So I see here that it's no addition or subtraction, so I can turn this into one big fraction and drop some multiplication signs on top and bottom. I have an x and an x squared on top and bottom respectively. So the x to the 1 is outnumbered by the x to the 2 by 1x. So I have x to the 1 remaining on the bottom. I have 3's and they do not cancel with the 4 or the 8 at all. They do not reduce. So on top I'm left with 3 times 3 is 9. On the bottom 4 times 8 is 32, and then I have my x. So this would be my final answer. Going down a little bit farther to number 19. This one has addition or subtraction, so it's kind of like before where it gets a little bit complicated. But before you go too far, make sure you rewrite the problem as multiplication. So let's do that first. We have 2v squared plus 6v over 2v squared plus 4v times the flip of the second term. So v plus 2 on top, 3v on bottom. So we took this one and we flipped it and then we turned it into multiplication. So working from this, the most tempting thing for people to do is to say 2v squared, 2v squared. Does not work that way. Because of the example we talked about earlier, you're canceling through addition. That would be like saying 5/9 is equivalent to 4 plus 1 over 4 plus 5. And then canceling out the 4's and saying 5/9 is equal to 1/5. We know that that's not true. It does not work. You have to be careful with that. So you cannot immediately cancel those out. What you have to do instead is factor. So if we look at these and see what they have in common, they both have a 2 in common. They both have a v. Our leftovers then is going to be 2v squared divided by 2v is just v. 6v divided by 2v is just 3. So we cross that original out. On the bottom, again, we have a 2 in common between the 2 and the 4. We have a v in common. 2v squared divided by 2v is just, it is not 2, it is v. 4v divided by 2v is 2. The v's cancel and then 4 divided by 2 is 2. So we cross out that original. Moving over here, there is nothing we can do to reduce that. I'm just going to throw parentheses around so things don't get lost. And then a 3v here. So we have a 2 on top and a 2 on bottom that can cancel each other out. We have a v on top, a v on bottom that can cancel each other out. We have a v plus 2 group that can cancel with this v plus 2 group, because remember, when you have it fully factored, it turns into one giant fraction that you can cancel anything top to bottom, even if it's diagonal. And the only thing I see left right now is a v plus 3 up on top and a 3v on the bottom. Yes, the digits are the same. They both have 3's, they both have v's, but one is a multiplication problem on bottom, one is an addition problem on top. They are not the same value. So our final answer is v plus 3 over 3v, and that does not reduce. There's nothing that fully factors from the top and bottom that you can cancel. Good luck.